Okay, tonight what we're going to talk about is elements, compounds, and mixtures. And elements are all one type of particle. So you're talking they're all the exact same type of thing. You can have multiple of them, but they're all the same particle. So if I were drawing it, it would be all the same circle, or you could have multiple of them together. Those would all be representing an element. Where are you going to find your elements? Well, all you need to do is look at the periodic table, okay? And the periodic table is the chemistry's cheat sheet per se. So all you have to do is look at it. If it's on the periodic table, it is considered an element. A compound is when you have two or more particles that are chemically combined. And by chemically combined, we mean bonds. And bonds are where they are sharing things that we will be talking about later, but you have two or more particles that are chemically combined. And when we're talking about particles, you are talking about elements. So a compound has two different elements or more that are chemically bonded. And then we have mixtures. And a mixture is assortment of elements and or compounds. So you can have multiple elements together, you can have multiple compounds together, but it is some sort of a blend of an element and or a compound. So an example for this guy would be when you have NaCl or H2O, okay, and that would be water. So this would be salt combining with water, so you would salt water. That would be considered a mixture. Now, how you would identify these during a non-pictorial demonstration is an element will be found on the periodic table, so all you have to do is look to see if that name is found on the periodic table. If it is, it's good. If it's not, move on to the compounds. Okay, for compounds, what you're going to do is you're going to look for either two or more elements that are right next to each other. So notice you have Na, which is an element of sodium, and it's written right next to chlorine, which is Cl, which is also another element. So if they are written like this, that represents that they are bonded to each other, so that would be a compound. Or you'll see some sort of element, which is sodium, name, followed by a word basically you don't really know right now, such as chloride. That would also be a compound. So if an element will be on a periodic table, if you can't find that, you go on to a compound. A compound will have some sort of symbol written after it, such as NaCl, or two words, the first word being an element found on the periodic table, and the second one being some sort of word that you don't even really understand. A mixture is where you have multiple elements or multiple compounds together. So the next thing is that we're expecting you to be able to draw elements or compounds. An element will be all the same substance, so you're looking right here that they are all the same circles. Compounds, you have two or more elements that are chemically combined, so you are talking about one type of element. Here's a different type of element or particle, and they are bonded. By us, whenever you draw them touching, that actually represents a bond. It is not by accident. So if you ever see two shapes that are touching, that represents a bond. That is not by accident. And if you accidentally do make them touch, then you need to erase it and start again. A mixture, a drawing of a mixture would be, here's one element, here's the same element, or same type of element, and then here is your compound. So you have an element and a compound coming together, so that would be your mixture. An element versus molecule versus compound. There is surprisingly a difference between all of these. An element, even though a lot of times they're used the same way, an element is they're all the same type of particle. A molecule, to be a molecule, you must have a bond, and that can be either made of the same element or different elements, whereas a compound, you also need a bond, but you are made up of two or more different elements. I think it comes better if you look at it visually. So we're going to look at this guy over here. This one, because it's only one particle, it doesn't have a bond, and they are all the same, this would be an element. Okay, if you look at this one right below, they are all the same, so this too would be considered an element because they're all the same. If you look at the bottom one, you have one type of element and another type of element, and they are bonded, so therefore that would be a compound. Now, if I need to worry about molecule, a molecule just has to have a bond. So this one does not have a bond, right there. But this one does, and so does this one. So both of these are molecules. Okay, so that's elements, compounds, mixtures, and now we're going to be talking about physical and chemical changes. So a lot of times you'll be interacting things, different compounds, different mixtures, different elements, and you'll see or experience something where you notice a physical or a chemical change, where it actually looks different than what you started with. A physical change is where they actually look different, but they are made of the same things. So it's a rearrangement, meaning that they're different, but you're not changing the actual substance of what it's made out of, what is bonded with what, etc., etc. What a typical one is a phase change. Phase changes such as melting, boiling, freezing, any of those, what you are doing is, yes, they do look different, but they are identical in what they are actually composed of. So if I have ice and I allow it to melt into liquid, it no longer looks like the solid that it once was, but it is still made out of H2O, where you have two hydrogens that are bonded with one oxygen, and so that would be a physical change. Whereas a chemical change, you are literally changing what things are bonded with one another. So yes, it too would look different as with a physical change, but you are actually making something new. So it's a new combination of these bonds where you're breaking or making bonds. So a lot of times you're going to have to be able to identify whether it's a physical or chemical change. The biggest one I can say as of this moment is that you want to try to look for if it's irreversible or not. Irreversible means you cannot go back. Okay, so if you cannot go back to this original substance, then it is going to be considered a chemical change most likely. One example is when we put Alka-Seltzer in water. There's no way that you can undergo to be able to get that tablet of Alka-Seltzer out of that water. So that would be a chemical change. Also, burning of paper. There's no way that you can get that paper back to where it once was. Whereas with a physical change, if I had melting of ice, all I would have to do is refreeze it and it would go back to being frozen again. This is a picture of what a physical change would look like. So you have your particles and they are in the solid form. If you wanted, you could show them vibrating, okay, because that's what they would be doing. But all I'm doing is going through a physical change where they are spreading out, but notice that these weren't bonded to one another really, and then now they still are not bonded to one another. So this would undergo a physical change because they are not breaking or making bonds. All it is undergoing is a physical change of going from a solid to a liquid. Here, on the other hand, is a chemical change. If you look at what is bonded in this picture to each other, such as the clear circle and the hazy one that's filled in, and then look at the end, now I have the circle connected to the little two clear circles, and that hazy one now is connected to the black circle. So if I notice my before, I have broke a lot of bonds to make these new ones. Some big signs of a chemical change are gas formation, solid formation, temperature change, color change, light. These are great signs that when we're asking you to identify whether it is a chemical or a physical change to look for. If you notice that you see multiple of these signs, such as burning of fireworks, so if this is my example of fireworks, I do notice that a gas or smoke was formed. I do notice that it got hotter. I obviously noticed that they had a color change for fireworks and that I produced light. If you notice that more than one of these characteristics are seen throughout that process, then it more than likely is going to be a chemical change. Okay, it's not always a guarantee, but it's more likely. Now, gas formation, just to let you know, is, remember, gas formation is when you see bubbles. That would be an example of a gas formation. So even though boiling you see bubbles, you are not actually changing it, but you are just creating it into, putting into the gaseous state, so therefore it is not really a gas formation. For for a chemical change as opposed to a physical change. The solid formation, it's really important to know what happens with this. It's called a precipitate. We did talk about this a little bit earlier during our mass change lab, and a precipitate is where you have a solid coming from two liquids. A lot of times it just looks a little cloudy to you. Temperature change can be either positive or negative, so it can go hotter or colder. Color change, you notice maybe it goes from clear to red or whatever. And light, obviously you should see light being produced. Once again, you want multiple of these signs, but another thing, a classic one to look for, is whether it is reversible or not. Have a great night. That's your lesson on elements, compounds, mixtures, and physical chemical changes.